Alright, you guys better strap in for this one because this is honestly the most insane thing I've ever built, like literally ever. I mean, this is such a step up from random Arduino projects. Dude, this is gonna be crazy, okay? So just listen. I joined my university's robotics team last year, and we make a rover that competes at the CIRC, and my job was to build a steering system, because before, it was basically like ooga booga, drive one side of the rover faster than the other to eventually make it curve to one side. And that was like ugly, stupid, imprecise, definitely negative aura. It's just not good. They came home from competition and they all sat in a room and they were like, okay, steering, we all agree it's dookie. How do we fix this? So what they decided was to slap a motor on the two front wheels to make them turn individually. So this isn't like a car with a steering wheel. No, it's like two motors that just turn the wheels on their own axis. It should be pretty simple in principle. Now, the real question comes in, how do you control the steering? In essence, you need an interface between the rover's computer and the steering motor. And that's my job. I mean, of course, steering something is like a task that's like already been done a lot of times before, right? However, when we were looking for off-the-shelf components, they're just blummin' expensive. Like, we are not dropping $600 on two steering motor controllers. We are on a shoestring budget. Like, not even, like, we are on a shoestring budget with like one shoe. Alright, so what does all of this mean, like, at the end of the day? I have to build... Oh yeah, and just for reference, I keep saying, like, I gotta do this. I gotta do that. Yeah, I was working on this with my boy Vincent. He shows up in some of the clips. So yeah, it's kind of like both of us working on it. If it was just me, believe me, this shit would never have taken off the ground. Would have died in Shark Tank. Like, I'm out type shit. I have to build an interface between the rover and the motor with the following requirements. So it has to take in CAN bus messages, process them, and then send appropriate messages to the motors. Now the motors are 24 volts, 3 amps, so the power system has to account for that, namely with a 24 volt input and a motor output, which also means, okay look, so now you have a microcontroller, right? That to process the information, that's very much not 24 volts, it's gonna kill it. So you have to somehow step it down to, let's say, 3.3 volts. That means you have to have some power conversion hardware there as well, and on top of that, the motor has a relative encoder on it, which means that you have to have some sort of way for that data to come back into the board. So that's all of our requirements, but what did we actually end up doing? So let me give you the rundown on the final components that we ended up putting on our board. At the center of the whole operation is an STM32 microcontroller. It's about $12 and you can just run a program on it, super configurable, and it's just fantastic. Going out of the microcontroller down to the motor side is a DRV8874 motor driver. This thing is about $3.30, so what it does, it takes the lower power signals coming in from the microcontroller and it sends out the motor current needed to achieve that command. Apart from that, the messages coming in, like I said, are CAN bus. This is a special communication protocol, and you need a CAN transceiver to convert that to something that the microcontroller will understand. For this purpose, we're using an MCP2562. No, sorry, 2561. 2562 is broken. That shit's stupid. Short tangent. MCP2562, they should never have made it. Literally set us back months because we couldn't find out what the problem was on our board. And at the end of the day, it was one stupid function of the MCP2562 chip that was literally decimating our boards. That boards plural. Yeah, we lost multiple to that stupid devil microchip. So we switched to the MCP2561. So basically all we have to do after that is work with the power. So you'd have 24 volts coming in at the top, and you have to convert that down to 5 volts with the buck converter, and then with an LDO to 3 volts. So what a buck converter does is that it steps down the voltage without dissipating heat, and an LDO steps down the voltage with dissipating heat. You might ask, oh, why do you have two? Why not just one? At the end of the day, 24 volts to 5 volts is the best we could get for a buck converter, and then we have to do the final stretch with an LDO. After that, we just slapped a gazillion resistors and capacitors in various places, along with a bunch of Molex connectors. We also have a TVS diode to prevent voltage spikes, another inductor because it looks cool. As far as I know, I don't know what it's for. So everything I talked about up until now took about, like, let's say 5 months. This is like January now, January 2025. Okay, imagine this. You're sitting there in the snow, and then the doorbell rings, and you get a package with all your components and your board blanks. Now the question is, how on earth are you gonna get the components onto the board? Let me tell you. So what you do, you take your board, you slap it on the table. You put metal paste on the board where it needs to go. All right, now we're gonna do some PCB assembly. I got my stencil. Let's do this. Alright, second board done. Oh my god, this took so long. So you have your board with all your components. You set it up to test. And this took like another 3 months after the 5 months. Now we're at the 8-month total mark. In the 3 months, there's a lot of testing that went on. So yeah, there were a lot of issues in the software basically because it was my first time coding in C, much less on an ST, much less even using the godforsaken STM32Cube IDE software. That shit's a mess, might I add. Buttons the size of the grain of sand. Like, imagine if you have YouTube, right? Imagine you have YouTube, but like the play button is like the size of a grain of sand, surrounded by 20 other useless dipshit buttons that don't do anything, or even make your code worse. And then you have to like, if you ever want to play the video, you gotta click on that one stupid button. That's the run button, or the generate code button in the Cube IDE. And then imagine like you have windows that you want to see. Like, oh, I want to see my breakpoints. How do I get to that? Who the fuck knows? Anyways, I'm kind of skipping over all of that because it's disjointed, hard to follow. I even forget a lot of this stuff myself. After verifying the board's basic functionality, throughout the whole month of July was just testing. All right, so what's happening? Vince, do you want to describe what's going on?
Well, you fixed this.
I did fix this. So basically, you press the button, the motor spins, okay? Through Canvas, through this thing, through a custom board, through the jank chip that we soldered, through the alligator clips. Shit's awesome. Kevin, check this out. Look, you press the button and the motor spins. That's crazy, right? That's crazy, right? Oh, it's insane. Working is a big word. All right, after an open heart surgery transplant of the STM, it's alive again. This is the third board. You got anything to say?
Great job, doctor.
Appreciate it. Patient lives. All right, Rover steering test number 1. Vincent, chance of success?
Confident, 90%.
90%? And it turns. Yo!
Damn!
This is crazy! Where's the wood? Yo, look at this. So what happened?
So, we plugged in the motor wire
Yeah, we plugged in the motor wire.
while the board was on and trying to drive the motor.
We plugged it in while it was on. And then what happened?
We smelled some burning.
We smelled something off. And then the board kind of stopped working. So, we're gonna do some invasive surgery and we'll see what the cause was, okay? Alright, today is July 14th or 15th, I'm not really sure. We're making another steering board, 3 out of 4. James, this is my friend James, what do you have to say about it?
I'm just watching.
Just watching.
Good. He used some reflective ass tape though, I don't know why.
No, it's looking good. Alright, this is the vlog on the 16th of July. I got Quentin here. He's been doing a lot of work. Rover. What about Kevin? You wanna be in the video? You know how like the sports commentators discuss how the game is going? Alright, we got Vince.
How's it going?
Alright, we got Vincent on the tools right now.
Power supply running.
Do we have motor movement? It's not looking like it.
It's not looking good.
Hold on. Hey, wait.
He's being cautious. He's being cautious.
Don't be so negative.
I'm sorry.
What's up, dude?
I was trying to see if it was working, but we still don't have a clock on it.
Oh, right. That might help.
Okay, let's get a clock on it.
Alright, vlog off. Alright, check this out. So I'm coding at home right now. You know, the home setup looking good. And I want to add a calibration sequence that's going to trigger every single time the steering motor is turned on. Or the Rover is turned on, pretty much. Calibration sequence is going perfectly. As you can see, starts off moving super slowly. But once it hits the limit switch, oh, back straight, and now knows its origin. All right, we're at 135 right now. What are we changing it to? Let's say like 45, back to 45. So we're at 135 right now. Fire, that's so cool. And then we come to now. Steering pretty much works, but it's really unfortunate because the last day that we were able to work on it we did like the big test, right? On the actual rover in the frickin' parking lot, right? And I'll throw it up. In essence, there were two problems with our system, okay? Problem number one, the limit switch was not being hit. Is there like a couple of other things going on? Basically, the goober was not shaped in the right way, okay? And it was not triggering the calibration sequence correctly, alright? The second problem was that in the firmware there is one constant that wasn't set correctly, but then we just fixed it and it's fine, I know for sure that the firmware is fine, system is fine, and it'll probably be fine, okay? Like, okay, sure, we can't show it right now, because of a stupid problem that we're totally gonna fix. This can be super easy, and then in the next video, I will show it working at comp. It's gonna be lit. It's gonna be awesome. It's gonna go left and right, even forwards sometimes if it wants to. Don't even worry. We'll get this sorted right out. And yeah, so I guess that means you kind of have to subscribe to see the next video, right? Because you kind of watch this whole thing, and then you saw how it's made. And I'm just throwing that out there. You don't have to do it, but I mean, it's really the only sensible way to see the next video, right? Cool. I will see you in a couple days when we actually go to competition. Okay, bye-bye.